Here are a couple examples on one-sided limits and some other limits to refresh stuff. So, there's a graph of a function. You don't really have an equation for it, but you have the function in the picture and the asymptotes. So here's the red graph is a picture that has a vertical asymptote at x equals -2. It has a vertical asymptote at x equals -2. And then it has this horizontal asymptote at y equals 0 because the graph tries to approach the x-axis. So the limits that we've looked at before are, let's say, the limit as the function as x goes to infinity. So as you can see, as x goes off to infinity and the x values get larger and larger, the function value tries to approach 0. So that's what we say here for the limit as x goes to infinity, the function goes to 0. The same will be the true as x goes to -infinity for this function, because as the x values get smaller and smaller, the function values try to get closer and closer to the x-axis, and that is a horizontal asymptote at 0. If we wanted to look at some sided limits, that would look more, say, what happens around x equals -2. So if I was interested in looking at what the limit of the function does as x goes to -2, if we look at it from the right, that's what the little plus sign means. So you have to approach it from the right side of the graph. So that will be trying to get really, really close to -2 from the right direction, and you can see that it shoots off up to positive infinity. If you try to evaluate and find the limit of the function as x approaches -2 from the left, again, that's gonna come over here on the left side of -2 and try to approach that x value of -2, and it also shoots up to positive infinity. So here, whether you go to -2 from the left or the right, the limit of the function goes up to infinity. Okay. Here is another example of a graph. It has vertical asymptote at x equals -4, so something that made the denominator undefined. It's got a horizontal asymptote at y equals 2, so that had something to do with the way the rational function was defined. You can look as the limit of the function as x goes off to infinity. That's this direction. As x values get larger and larger and larger, the function value itself tries to approach the horizontal line at 2. So the limit for the function as x goes to infinity in this case would be 2. Okay. The limit as x goes to -infinity of the function, same idea. The x values get smaller and smaller and smaller. Where does the graph go? This graph tries to approach the horizontal line at 2, so it will also have a limit value of 2 as x goes to infinity. If you look at the vertical asymptote split, the 4, and you try to see what happens here, here's the vertical asymptote. If you try to look at the limit for the function as x goes to -4 from the right, okay, so you find -4 and you try to approach it from the right side of that asymptote, and you can see that the graph is going to shoot down to -infinity. All right, looking at the limit of the function as x goes to -4 from the left, try to use a different color here, that's going to approach this vertical asymptote of -4 from the left. So if we go to the left side of -4 and try to approach that x value of -4, you can see that the graph shoots in the up direction. So that limit, that sided limit, will go up to positive infinity. So sometimes the limits, as you approach values from one side or the other, will go in different directions. Sometimes they'll go in the same direction, but you have to be able to approach it from the left and from the right to be able to get the right answer. I know that I've covered it up. I can erase a little bit here. But looking back at what this graph did at 0, the graph itself actually went through the origin. There was a point there. So you could even look at the limit of this function as x goes to 0. So you're just looking at what happens as it goes to a point, and as it goes to 0 from either the right or from the left, it goes to the function value of 0. So in this case, here's a limit as x approaches a value, and the answer is another value. It doesn't go to infinity. And that's okay, because limit, again, it's just function values. It's just the behavior of the function. Whenever you're specifying whether x goes to infinity, negative infinity, a number from the left, from the right, you just have to look and see what the graph and what the function's behavior does for a function value in order to answer these limit questions.